Hello everyone, this is Professor Mahajan. We have started with field astronomy. We have seen so far the different terminologies related to the field astronomy. This is the what you can see, the celestial sphere. This is north celestial pole. This is south celestial pole. This represents your horizon, where exactly you are standing. How you can say this is the north? The north is related with where is the NCP, that is north celestial pole. This is the position exactly above head. This is called the zenith. This is the nadir. This is the ecliptic path. Already we have seen that. This represents you. The sun appears to be rotating around the earth. This is the celestial horizon, which is very parallel to the equator of the earth. Along with this, we have also seen that what is the great circle. You know that the great circle is the circle. Basically, it's a sphere itself, which is passing through the center of the earth. So this is the center of the earth as well as the center of the celestial sphere. So you can see this is passing through the center. Same thing can be shown here also, passing through the center. So you can see the center here. But those centers which do not pass through the center, we call it a small circle. So there are many great circles which will be passing through the centers. We call it the vertical circle. So you can see here is a vertical circle which is passing through the zenith and nadir. Similarly, this is one of the great circle which is passing through the center, but which represents the ecliptic path. This is one more great circle which is passing through the center, but that represents the horizon. Vertical plane, there will be star position. So this angular distance we called as the altitude. Now, as you know that the horizon surface, which is this plane and this plane, they are 90 degrees. Therefore, the angle made by this plane is a horizontal plane and this plane is 90 degree. So if you say that this is your altitude, the remaining angular distance we call as the 90 minus alpha. So what is the, here you can see, may not be clearly visible. So this is the alpha, we call it the altitude, and A stands for the azimuth. So this is the horizontal angular distance, and M dash you can see, and this alpha is the, you can show here with respect to this line. Please see carefully, this is not with respect to this line. Basically both are lying in the same plane. You can show this, but as it looks to be a three-dimensional diagram, so therefore you can see this line joining this. So this one is your alpha. Similarly, equatorial coordinate system. So we are suppose somewhere here. So this is the geographical north pole, exactly above in the same plane is the north pole, and you can say the star is somewhere here. Now if you want to say in equatorial coordinate system, this is your equator, this is one horizontal plane. With respect to this, in horizontal plane, so you want to know where is the star position. So the reference is this point. Now this point already we have discussed in the previous lecture, called the vernal equinox, and this angle towards the right side and above this one, this actually represents the star position M. So why it is called right ascension? So from this vernal equinox going right towards the right, and this is in increasing order, therefore it's called the ascension, and going up, this is north, so this will be called the declination. So declination will be represented as positive declination, the north declination, and below that this is the south declination. One more thing, this is the R circle. R circle is the circle which is passing through the poles. Similarly, what you say here, the zenith and the nadir point, this is the vertical circle, this should be, if we say that Z and the pole, that means one Z here, Nadir below here, similarly North Celestial Pole and South Celestial Pole. So therefore, from the through the 4 points, if we pass through this, we call it the observer's meridian. Now here is the North Pole, and this is below is the South Pole, exactly opposite that. So the circle passing through North Pole and South Pole, we call it as the our circle. Basically, it is shown as a North Pole, but it's a North Celestial Pole. Please try to understand. This is North Celestial Pole, and this is the South Celestial Pole. So there are n number of the hour circles passing through different points, right? Now, this is one more. You can say the declination. So if this is the declination, so what is the remaining is called as the co-declination. So declination is shown by delta. Okay, and this is the right ascension, which is shown by A. We want to know here what is it, how you determine the latitudes. Now, what is the latitude? Where you are standing, or any object on the earth, we want to know its a location. This can be known by the celestial coordinate system. Now you can see there are 4 possibilities. You can see now here we are standing somewhere here, and this is a horizon coordinate system. Now, depending upon where the star coming, imagine this is the sky above you, this is the horizon system, the below one you cannot see. Now if this is a sky, so where is the star one? This is, you can see star 1 S1. So there are 4 possibilities of appearing a star in the sky. One is the equatorial plane, that is if I say E, and the horizon, right? Question is that you want to know what is the, where is the equatorial. So we are going to see in subsequent slides where will be E. Similarly, the star may appear here. You can see here the equator is here and the zenith is here. So just like it is divided into different segments, the points, the zenith, okay, this is the north, they will be same in all the 4 cases. Now come to this third case. You can see now star will be appearing between what, the zenith and the pole, and the last one, the star will be coming between the pole and the north direction. So basically north edge, which is shown as, this is the horizontal plane, this edge you may consider as the south also. Now come to the first point, or the first case. You can see here, now what is the theta? Theta is the latitude you want to determine. Okay, now how you can say the latitude? The latitude will be with respect to the equator. Okay, now where you are standing, as it shows that a particular location, geographical location on the earth. This equator may come like this equator may come like this, in any direction depending upon where you are standing. Now this EQ shows your equatorial plane, and with respect to that, this will be your theta. Okay, similarly, if you say this one is making 90 degree, which one? This one is making 90 degree, because the equator plane and the north pole, they will be representing the 90 degrees. So therefore, if it is theta degrees, this one will also be theta degree. Now this theta you want to determine actually. So you want to know where will be the Z. Now what is Z? It's called as the zenith distance. Now what is the zenith distance? The zenith distance will be between the Z and the star position. This is the called as the zenith distance. This one is also called as the co-altitude. So what is the altitude? You can see this S1H is nothing but your altitude. Now coming to the second case. Now this is the S2. Now this ZS2 is nothing but your zenith distance, and this one will be your altitude. Coming to the third case, S3 is here. Now where will be your zenith distance? Okay, so zenith distance will be this distance. Now you may think that your altitude will be from here. No, altitude will be always between 0 to 90 degrees. The moment it crosses here, you have to start measuring the altitude from opposite direction. That means this one. So this one is nothing but your altitude, and what will be this one? This one will be your zenith distance. And the last one, your star may appear between the pole and the north direction. So in that case, theta will be, this is the equation. Now what will be this value? This is nothing but your altitude, and this Z(S4) is nothing but your co-altitude. Now you may arise the question that how this will be coming. This is very simple. What is delta? Is the declination. What is the declination? Declination, this is the equatorial coordinate system. That means you have to measure with respect to the equator. Now you may see that this is your equatorial plane. The delta will be from E point where is star coming. Definitely you may not be able to measure or see, sorry, you cannot see yeah, sorry, I'm very sorry. You may see the star above this one, but where will be E, you want to know. And this will be equal to what is the value of this theta. So that means once you calculate what is the theta value, you may in the sky locate where will be your equatorial plane. So this ES1 is nothing but your declination towards the south. So this one from H to S1 is nothing but your altitude. Then Z to S1 is your co-altitude, and if you see E to S1 is if your delta. So easily you can find out what is the value of theta, because all this coming into the first this you can say quadrant or this segment. So easily just by the arithmetic operations you can say theta, you can calculate this one. When it comes to here, theta is becomes your Z plus delta. Now when this is coming S3, this theta is equal to delta minus Z. You can just see here the difference between delta minus Z, and this is a delta, sorry, Z minus delta and delta minus Z. And the last one when it's coming out to be this theta is equal to 180 minus delta plus delta, Z plus delta. So what you have to do, either you can remember all the four cases, make sure that you may not forget or you may not make the mistake where the star lying and the corresponding distance. So if you fail to correctly write the formula, then your entire calculation may go wrong. Okay. Now we'll see simple problems. The meridian altitude of a star, you can say the altitude, or simply meridian altitude of a star was observed to be 66 degree 40 minutes and 20 seconds on a certain day. The star is lying between the pole and the zenith. Now note it down that in numerical always the star position will be given. That means in which case you have to identify first. The declination of the star was 54 degrees 12 minutes 10 seconds. Find the altitude of the place of observation. Okay. Now on a certain day, suppose we are standing here, this is your geographical location. Irrespective of anywhere, you can identify the value of theta. This theta may be coming here or may be going down. Anywhere you can calculate. To start with this, we have to first see the problem statement. Where is the star position? So you can say star position is between the zenith and the pole. So diagram will be, you can see where E with the pole P. This is the, where is the N, where is the H? H is nothing but your south, that is opposite that. Now here you can see there is the P1, that is the south celestial pole. P stands for the north celestial pole. Okay. So you identified where is the star. Okay, this is the S3. Now if you fail to recognize or recall, rather I'll say recall the formula for this, you can easily again derive the same formula in within fraction of seconds. You can say the star position is between Z and P, the zenith distance. Now the zenith distance will be Z to this star position. Now what is this from N to S3 is nothing but your altitude, and that altitude is given 66 degree 40 minutes 20 seconds. So Z is equal to 90 minus alpha. So if we, this is alpha value, and if you subtract it, this value is coming out to be 23 degree 19 minutes 40 seconds. Now what will be the value of latitude, this theta? So you want to know what is the theta value. Okay, this theta is value nothing but where from the equator this value and one and the same meaning. So latitude is equal to theta is equal to delta minus Z. So what is the value of delta, which is also given as a 54 degree 12 minutes 10 seconds in the problem. So if you subtract it, try to calculate this value. Then last we will say the another case. If meridian altitude alpha is given 65 degree 36 minutes 20 seconds on a certain day, the star lies between equator and the zenith. Now where is the position of the star? Between the zenith and the equator. So this is the star position. The declination of the star given as 26 degree 12 minutes and 10 seconds north. Find the altitude of the place of the observation. Okay, I'll start with this, identifying where is the position of the star. Now, everywhere in all the four cases, you need to calculate what is the zenith distance, that is 90 minus alpha. Now, what is the alpha value? Alpha value is, what is the alpha value? 65 degrees 36 minutes and 20 seconds. So here will be definitely this value will be always will be less than 90 degrees. It will never cross the 90 degrees. So this will be with respect to the horizon. Okay, and this will be is your that equal to your altitude value. Now zenith distance 90 minus this value, you can calculate the easily what is the zenith. I have not written this task, I will leave up to you. To find the latitude, latitude theta is equal to delta plus Z. So delta value is given 27 degree north. So where is the north? Is the, this is the entire is the nothing but your north. It doesn't mean that it towards the north. North means in the northern hemisphere. So 27 degree 12 minutes 10 seconds. So 27 degree 12 minutes 10 seconds. So that is your delta value. Delta value will always be with respect to the equator. So this is your delta value, and this is value Z value. So you can calculate. See here itself, it is very easy to calculate what is the theta. This plus this is nothing but your theta value. So easily you can calculate what is the 27 degree 12 minutes and 10 seconds. I hope you understood this. So tomorrow, next lecture, we will see what is the astronomical triangle, or we can also call it a spherical triangle. Thank you very much.